Lab 2 Charge Seek Revisited. So on. So introduction. So the purpose of this lab was to observe and calculate how two charge tapes, modeled as line charges, exert an electric force on each other. And we're going to use this to estimate the amount of charge on each tape and compare the result obtained in lab 1. So the results that I got for my point charge in lab 1 was 1.4 times 10 to the negative 8 coulombs. And the line charge that I got for this lab was 2.5 times 10 to negative 8 coulombs, so quite a bit of difference. So some fundamental principles that I'm going to be using. Pretty much the same as lab 1, I'm using Newton's second law. And this is useful since we know that the net force is 0, which means that it should be equal to the electric force. Rather, it should just cancel out and the net force is 0. And also Coulomb's law, which pretty much again just calculates the difference between two charged particles. This will be attractive and or either repulsive. So the results from lab 1. This is we got the mass of the tape to be 0.002 kg, tape length to be 0.2 meters, the tape width to be 0.02 meters. Sorry about that. And the distance to be 0.03 meters. And the charge is 1.4 times 10 to negative 8 coulombs. So for the line charge model, this is our code, and there are definitely parts of it. And from the start, I used all the same constants. And in the code, we can see that there's the E-field function, which was taken from lab 0. The line charge code over on the right breaks the tape into, well, we use this to break the tape into n segments, and so basically it kind of just creates a rod, which is essentially more effective to calculate the entire thing rather than having a single point charge. And I chose 50 to have the number of tapes to be added together. And in the bottom right, this is the nested for loop, which was designed to find the electric field on each tape n, and then kind of just and then add that together because to use superposition, and the total of that will be the electric field and basically the electric field, the electric force on the top tape by the bottom tape. Sorry. For my results, I got that well, on the left is my calculations for the force of the rod, and I use that equation to get the force of the rod, and then over on the right is the electric force I got and the gravitational force. Um, I think they're somewhat pretty even, so it makes sense because it's floating. So some possible sources of error. There are definitely measurements that aren't precise, um, like the mass, length, etc. And there's also some forces, a lot of forces in the surrounding environment that aren't included. And we pretty much made the system of the tape. We made the system to be tape A, and everything. The only thing acting on it was just gravity and the tape B, which is incorrect. Um, and then we assume that each tape has the same amount of charge, and then the charge tape, and then the tape charge is uniformly distributed. So why do these estimates matter? Or why do these estimates differ? And which value is more likely to be closer to the real value and why? Well, kind of like an integral, the line charge calculation is going to be more effective because it breaks the tapes down into individual different pieces along the tape, and even increasing it, by 100, 150 could have even made it more accurate, but I believe 50 is enough, or rather, like, it's pretty close. And then, yeah, I mean, we can clearly see the difference is 2.5 times 10 to negative 8 for the line charge, and point charge is going to be 1.4 times 10 to negative 8. Thank you.